Hello and welcome to this tutorial in which we're going to talk about the chi-square test. The chi-square test is a test to know if two variables are dependent or independent one from the other. For example, in this case, we're going to study if the time you watch television per day, if the hours you watch television, is dependent or independent from how many years you have. We have this interview, and here we have the results out of a total of 129 people. For example, 24 had between 0 and 5 years, and 7 of those 0 to 5 said that they watch more than 6 hours of television per day. So this study that we're going to do, this test, starts by writing the null hypothesis. The null hypothesis is a hypothesis for the independency. We will write here that the hours you watch television is independent from the age that you have. Okay, so this, by doing the rest of the test, we are going to see if this is true or not. Okay, that way we are going to see if the variables are dependent or independent one from the other. Now we start calculating the degree of freedom. The degree of freedom is related with the accuracy of the test, and we have like a way we have different accuracy levels, but they depend on the degree of freedom. So the degree of freedom is like a reference for the test. In this case, the degree of freedom, we are going to calculate it like row minus 1 times column minus 1, as we always do, and we're going to see how many rows and columns we have. For example, we have 1, 2, 3, 4, 5 columns and 3 rows. That's why we are going to write 5 minus 1, so 5 minus 1, that will be 4, times 3 minus 1, that will be 2, because we have 3 columns, that will be 3 minus 1, the columns minus 1, and the result for this will be 8, because we will have 4 times 2, that's going to be 8. Okay, now many of these exercises ask you to find the expected number for some of the categories that we have in the table. The expected number is like the number that it would be there in the table if the relationship was perfect, was a perfect dependency. So for example, the expected number for 6 to 12 that watch 3 to 6 hours, that will be this value here in the 8. We're going to calculate it always like the total of the row times the total of the column divided by how many people we got in the interview. That will be the total of the row, 38, times the total of the column, that will be 30, divided by the total of people that we have in the interview, that is 129. So we perform that in the calculator and we will have that value. So we will do 30 times 38 equal, and then we divide by 129. So we have 11.20. Okay, that will be the expected value, equals 11.2. Okay, then we are going to perform really the chi-square test to know the chi-square value, the chi-square calculated value. Okay, that's we do with the calculator. We're going to go for the menu for statistics, and we're going to go to test, and then we're going to go to chi. And then we are going to write here in matrix A the values that we have in the table, and in matrix B the expected values are going to be given by the calculator. So here you go to matrix here, and you write how many rows and columns you have. We have 1, 2, 3, 4, 5 rows and 3 columns. So we start writing like 5, then we press the execute, then 3, then execute again. If you don't see the same shape that you have here, change the numbers. So we enter the results: 10, 7, 7, 12, 8, 10, 15, 6, 9, 5, 8, 12, 8, 9, 3. Okay, you never put the totals. Be careful of that. You never put the totals. Okay, then we press exit again, and we go to execute, and then this is the chi-square calculated value that we found, 9.95. In some exercise you can also work with the p-value, because you can compare this chi-square test, this chi-square number, with the critical value or the significance level. So you use this one for the critical value and this p for the significance level. So in this case we are going to use the chi-square that we calculated, that is 9.95. So we are going to write here 9.95. okay, this is our chi-square that we have calculated. Okay, great. Now what else we have? Knowing, okay, here we give our conclusion. Knowing that the critical value at a significance level of 5%, which is the normal stuff, is 15.51, state a conclusion. I mean, we're going to say if this null hypothesis that we wrote, that they were independent, is true or not. In this case, what do you think? If the chi-square that we have calculated is bigger than our critical value, I mean, if the chi-square that we calculated is bigger than the critical value that we have here, we are going to reject the null hypothesis. So we are going to say that they are not independent, so they will be dependent. In this case, as we see that the critical value is 9.95 and the significance and the critical level, the critical value is 15.51, we are going to say that these variables are independent because we can't reject h0 because this one is not bigger than this one. In other words, if this value would be bigger than 15.51, we will say that this is untrue, so they will be dependent. But in this case, as this value is smaller, we are going to not to reject this, so they will be independent. Okay, just like that.